there is if you actually do to check any sort of integral, how do you check an integral? What do? You take the derivative, right? So on this one, I tell, we could do this. If you hadn't seen it, we would have done like d dx of x e to the x. And what do you need to use if you're going to differentiate that? The product rule. So the derivative of the first times the second plus the first times the derivative of the second. So if you do the derivative of this, you end up with almost the same thing, but what's there? There's like this little bit added on, right? There's this little bit added on. So if you start playing around with this, and if I gave you 5 to 10 more minutes, I let people just throw terms up there to see what's going on. Anybody figure out what the integral actually is? It's related to what we just did. Yeah, Tammy.
X e to the x minus e to the x.
Yeah, in this way, that is actually it right there. That's actually it, because in this case, a lot of static behavior is really helpful. This, when you take the derivative of it, balloons out into this, right? Well, what's the derivative of this? Itself. So that just sticks around to get nuked by this. Does it always work out that nicely? No. No, it does not always work out that nicely. There's a lot to keep track of. It can suddenly get very easily really, really, really hard to manage. We learned that quickly when we tried to do some deeper things with functions that we ended up needing Riemann sums for. It gets really nasty real quick. So, what am I talking about? Well, like this one, for example. This one does not quite have the nice feature that the first one did. What's the nice feature that's missing from this one? E dx of theta cosine theta. If we did that one right there, you have the derivative of the first times the second plus the first times, what's the derivative of cosine? Negative sign, like this. So we're like, oh, so we have cosine theta minus theta sine theta, right? So we're like, huh, it's almost there, right? Seems like it's almost there, but what we don't have, like, this isn't represented down here. So we can't just take away this. And the other problem is, if we just took this away, when you take the derivative of this, does this stay the same when you take the derivative? It doesn't, right? So it becomes, you can get really close to it, but there are so many different ways you can go that you have to have a way of keeping track of it all. So I'm going to show you something that I think I left in there in totality. If I just take the derivative of two things, what rule is on the board right there? That is the product rule. So all I've done here, what have I done here? What have I done to get from here to here? I've anti-differentiated both sides. So if you differentiate, this is true, right? If I integrate both sides, well, what's the integral of this? Oh, there we go. FTC, fundamental theory of calculus, you're back where you started. Oh, you do this. I haven't done anything to this yet, right? But what can you do with the sum of integrals? The sum of, if you're integrating the sum, you can split it up into this. And then, the thing you've seen before in different forms is this thing in highlighter. You know that, so all I've done here is I moved, in this case, I picked this one to move over. Could you pick the other one to move over? Absolutely. Now, just to standardize it, so this is the justification for integration by parts. This is the methodology. Just to standardize it, this is the one I would like you to memorize right here. This is the one right here. I don't know why mathematicians paired up variables that look the same. Think about it. X and Y are paired together, and they're not functionally that different, right? M and N, P and Q, U and V. I don't know. But it's so ingrained that you have to get used to it. It's just weird. I mean, I think they were chosen specifically because they look the same. I don't think it was a good choice. But the idea is, the way you memorize this, if you haven't memorized it, or the way I memorize it, is I always know that one of them is primed, right? And then the other one is primed over here. That's how I remember it. What do you think the most common mistake by far is when people use integration by parts? What do you think the most common mistake by far?
They screw the priming.
What do you mean they screw the priming?
Like they'll have U prime on both sides.
Ah, yes, exactly. It's not a process. People understand theoretically that if they make the right choices for U and V prime, they're good to go. But if they apply this formula wrong, if they literally use it wrong, then what happens? Like unhappy things. Or you get the wrong thing and you think it's right. So you need to make sure that this is clear. UV prime, UV, U prime V. And U and V are both in terms of just what term? What are U and V both in terms of in this case? What are they in terms of? Exactly, because what calculus are we still in? Single variable calculus. Will we get to do integration by parts in multivariable land? Oh yeah, it's really fun. good time. You just have to keep track of it all. Oh, little trees and stuff. The way I set this up, I like seeing this, and I'd like to standardize this if possible, just so I can see the same type of general starting point. Are there sometimes multiple substitutions? Yes. But generally, I like to see u and v prime like this. So in this case, anybody want to guess what u is going to be? Or what do they want to choose for u? ln of x. And what's interesting is once you choose u, everything else is forced. Everything else is forced, because if that's u, what's u prime going to be? What is it? 1 over x. And if that's in it, we need two things that multiply together to get this, and it's u and v prime. So what does v prime have to be? 1 what? Dx. You say 1 dx. Right. So then what is v going to be? X. Exactly. We're turning this into, we know that the integral of u v prime dx is going to be equal to what? uv minus what? The integral of what? u prime v dx. So this right here, the first part, has to correlate to this. Are we? So now, what's u times v going to be? It's going to be ln of x times what? Times x minus the integral of what? u prime v. So it's 1 over x times what? And what's a good thing that we're seeing right now? What's the nice thing that just happened? Yeah, we have x ln x minus the integral of dx like this. Now what are we missing here? What did I not write in? What have I not written in so far? Yeah, so we have to go from what to what? 2 to 3 and? Like this? So what's the integral? Oh, so what do we have here? We have now this is equals x ln x minus what? Well, what's the integral of dx? Me through it? Did I actually give you a nice one to begin with? That's so unlike me. I usually choose the horrible ones. What does u equal? What should I start with u? Why did you choose ln x? The derivative's nice, correct? So that makes v prime equal to what? X to the 6. And then you go up, and what do you end up with? X to the 7th. And we decided we wanted to do this. I got it. Don't worry. Don't worry. Don't worry, Kevin. It'll be okay. Sorry. It's Ryan. Sorry. Sorry. So, uv. uv, what do we got here? ln, we got 1/7 x to the 7th times ln x minus the integral of what? Say it again, Pinky.
1 over x dx.
Yep.
Times 1 over 7x.
Nice, like this, exactly. And what this one's also, oh, this is indefinite, right? Okay. So what do we have here? 1/7 x to the 7th ln of x minus 1/7 the integral of x to the 6th dx, like this? Is that correct? So what do we end up here with? 1/7 times x to the 7th ln of x minus what? Like this? Yay! Did that work? I pulled the x/7th out, but then when you integrate, you get another x to the 7th, right?
Yeah.
Oh, that can I pull out the x to the 7th, you mean? Yeah. Are there different ways we could write this? Yes. Is that okay? Yes. Don't be that kid who you stop here. It's okay. It's really okay. There's nowhere else I want you to go. The only time you're going to be forced to do it on the AP test is when they give you multiple choice answers, and sometimes the multiple choice answers get cleaned up a lot. Like they write them in super factored form. So just be prepared for that. Let u equal to begin with. Yeah, I like u equals x squared. So what does v prime therefore going to equal? Sin of 4x, we like the dx, nice. So u prime is equal to 2x dx, and v is going to be what? Exactly, very nice. So when you write this out, we know it's going to be u times v. So what do we end up with? We end up with negative 1/4 x squared cosine 4x. Is that correct? Plus the integral of what? u prime v, right?
Yeah.
So 2x dx times negative.
Isn't it minus?
Oh, minus. Thank you. Yeah, it is minus. Yes.
You can cancel the negative.
You can. I just want to write it out in totality at least once, like this.
Yeah.
So yeah, you end up with negative 1/4 x squared cosine 4x plus what? 1/2, correct?
Yeah.
Plus 1/2 integral of what?
Um,
X cosine 4x dx. Is that correct?
yeah.
So what's the issue now? Like, what did you just run into?
That you don't know how to find it.
Directly, right. You can't just like pull that out of your head. That being said, this is very similar to this, but what's the one nice thing you've run into so far? What's one thing that makes this nicer than this thing?
But there's a lower power.
Lower power. You fight for little things, right? You fight for little tiny things. So if we do this again, we're now looking to do just this by parts right here. What's u going to be this time? So u prime is dx. So v prime is going to be cosine 4x dx. So what's v going to be equal to? 1/4 sine of x. Sine of 4x, thank you. So that's going to be equal to u times v. So it's going to be 1/4 x sine of 4x minus the integral of what? Dx times 1/4 sine. Is that right? Did I pull that right? I think so. So end up with 1/4 x sine of 4x minus 1/4 of sine 4x dx. Is that correct? Where's the one? Where did I kill a half? Oh, I'm doing it at the end. See, I was sorry. I should have been more specific. Let me box it here. I meant this right here. Is that okay? Yeah, I need to be very clear. That's what we're working on right now. Absolutely. So we end up with 1/4 x sine 4x minus 1/4 times what? It's the integral of sine 4x. You've already done this a bunch of times. What? Negative, right? Cosine of what? 4x dx, like this. So there's no dx, thank you, because we've now done the integration. Thank you. Very nice. So we end up with 1/4 x sine of 4x plus 1/16 of cosine 4x. So what's the final answer going to be? We'll go back to red here. We end up with negative 1/4 x squared cosine 4x plus 1/8 x sine 4x plus 1/32 cosine of 4x. What do we think about this? Plus what? Plus c. How do we feel about that? Yeah. Try here. Anybody want to guess? Anybody want to try something? What u do you want to use? Yeah.
My guess, when
Yeah.
I do it out,
Yeah.
is that if you let the if you split up cosine theta and cosine theta.
Oh, okay. Hold on. Pause. So here's one choice. I'll give you two choices. One choice would be letting u equal cosine. Another choice would be letting u is equal to what? Cosine squared theta. Either one. We've seen both cases be really to work, right? You let the dx be its own thing. The key thing to remember is the dx can be one of the elements, right? Which one do you want to use? Do you want to use u as cosine or u as cosine squared? Cosine? Who has cosine? Who wants cosine? Okay. So if that's true, what does v prime have to be? Cosine theta d theta, right? So what does u prime equal? Negative sine theta, what? D theta. So what does v equal? Sine theta. Okay, it's kind of nice. You know, it's interesting. There isn't a definitive path. Remember those rules we saw that were like, pick things that get easier or harder? This is kind of like, man, okay, we're there. We're not feeling anything yet. But we haven't run into a wall yet. So this is going to equal what? What's u times v? Cosine theta times sine theta minus, what, at negative sine d theta. Oh, sine theta, I'll get that in there. Sine theta d theta times what? Times what? Sine theta. So we're like cruising along. We're like feeling good because things are working nicely. We're like, ah, this is cool. Plus what? The integral of what? At this point, you run into a certain happy tragedy. which is, you might think to yourself, this is, no punchline, I don't want the spoiler yet, but what's nice about this is things have folded together nicely, right? You're like, oh, this is clean, right? But where are we now? We're pretty much where? We're pretty much back to where we started. So you're like, at this point, what might you think? Oh, maybe there's a different substitution, right? I will tell you right now, we are on the right track. What did we do in the last problem? Did we do parts before? Yeah. So let's use the same lesson. In this case, let's use the same lesson. Switch to blue here on this right here. What do we want u to be? Sine theta. So u prime is going to be what? Cosine theta d theta. So what does v prime equal? Sine theta what? D theta. What does v equal? What's it equal? Help me. Negative. I need speech that humans can hear. There we go. So this blue is going to be what? U times v is going to be what? Negative sine theta cosine theta minus what? Cosine theta d theta times what? Negative cosine theta. Is that correct? So where are we now? Where are we now? Plus what? Cosine squared theta d theta. So now we're seemingly literally back to where we started, but let's write out everything. Let's write out everything. What were we trying to integrate in the first place? What was it? The integral of what? Cosine squared theta d theta, right? And that equaled this. We have to bring this down. What is that? Cosine theta, what?
Sine theta.
Sine theta, right? You with me so far? And then what do we have to write out? Minus what? Minus sine theta what? Cosine theta plus what? The integral of what? What's the issue here? Did something just cancel out? So what happens when this happens right here? Oh, that goes away, right? So what are you left with? Can someone tell me clearly what we're left with? We're left with a true statement. We're left with the integral of cosine squared theta d theta is equal to the integral of cosine squared theta d theta. So what does that mean about our work? Is anything wrong with our work? Theoretically, no. There's nothing wrong with our work, but does this tell us anything useful? No, we're going to do something. I know what we're going to do. I got it. So I'm just giving you examples of paths. We did everything correct, but we ended up with 5 equals 5. So there's a detour we could have taken where instead of using the hammer of, okay, if it didn't work the first time we did use substitution, let's do it again. I want to go back and look at this box right here. And I'll switch to, what do we got here? Do I have a, I'll switch to, sure, green. What's a substitution you could make right there? Anybody want to guess what substitution you could make? What is sine squared? What is sine squared? Yes. So what do you have here? You could write this instead as the integral of what? 1 minus? Correct? Do you agree that that's the same thing? The integral of sine squared theta d theta, do you agree that that's the same thing? You with me so far? So what do you have here? You have the integral of d theta minus the integral of cosine squared theta d theta. Is everybody with me so far? So let's go back and look at what we have here. So this, what do we now know? From the beginning, we still have this. We know that, I'm going to use highlighters here. We know that this part right here is equal to this plus our thing over there. So what do we have here? We now know, it's important to see the whole thing, the integral of cosine squared theta d theta is equal to sine theta cosine theta plus the integral of d theta minus the integral of what? Cosine squared theta d theta, right? Is everybody with me so far? All I've done is, so what I took here, do you see the underlines there, Izzy? The blue underline? The first two parts are still cosine sine, but then we had the sine squared theta in the blue box right here. But instead we broke it into 1 minus cosine squared, and we separated it out. What can we add to both sides? Yeah, so what do you end up with? 2 times the integral of cosine squared theta d theta is equal to sine theta cosine theta plus what? Plus theta. Like this. And then plus c. Doesn't really matter where you put the c. Put the c at the end. We'll wait till the end. What do we divide both sides by? Cosine squared theta d theta is equal to 1/2 of sine theta cosine theta plus a constant. Boom. So what's the cool thing here? Sometimes if you keep on using u substitution, you're going to end up with this infinite oscillation that doesn't help you. You're going to get to 5 = 5. But if you can build the exact same thing on the right as your only hanging chad, so to speak, where can you put this? On the other side, and all of that messiness turns into 2. There are tons of ways this can happen. Is this a nice answer? Relatively. This is relatively a nice answer. Relatively. Can't wait.